Okay, so this last video is to show you how to put individual points along the path to represent where the ball is every quarter of a second. So I'm going to show you how to do this with your calculator. If you have a graphic calculator, you can just follow along. If you don't, you have a graphic calculator, number one, you should get one. Number two, you can simply do the stuff that we're doing, but you're going to have to do more calculations than what we're about to show. All right, so what I'm going to do is we're going to use this, which is the x of t, and this, which is the y of t, and we're going to be plugging in like 0.25 for a quarter second, and then 0.5 for a half second, and then 0.75. Now we could do that manually, but it's a lot of like plug and chug, and it's super annoying. So I want to show you a faster way to do this. So I'm going to go over to my calculator. Now, when you have x and y, and they both depend on time, like we have in this thing, that's a form of mathematical system called parametric equations. Parametric equations are where x and y are both dependent variables on time, rather than our normal thing where x is the independent and y is the dependent. So your calculator actually has a parametric mode. So what I'm going to do is I'm going to go to mode. And you see right here, we have this func par policy. This is function mode. This is what your calculator is normally in. Parametric mode is right next to it. So I'm going to go there, and I'm going to turn it on. Now, I'm going to be interested in entering my position equations, my x position and my y position, into my calculator. So what I'm going to do is I'm going to go to the y equals button, which is right here. And you see here, I have an x1 of t and y1 of t. That's a place where I can insert the x equation for time and the y equation for time. So I'm going to type those things in. It's going to take me a second because I'm having to use my finger here. Let me see. So the x equation was 46.688. Oops. 6885 or 6, let's say 6, times time. Oops, let's back that up. Times time. Now you're looking for the time button. You see this button right here, xt theta n. The reason it has all those things on it, you know, those 4 modes that were listed there, this button will give you the variable that fits whichever mode you're in. So if I hit this right now, it'll give me t. If I hit it in the normal like function mode, it would give me x. So that's my x equation. And now I'm going to enter my y, which was negative 16t squared. And then it's plus 58.6956 t plus 1.3. All right. So now we've got our 2 equations that are, now we're not going to graph this, we could, it's going to look much like the Desmos thing that we produce, and Desmos is just way easier to use. But the calculator can do something here that Desmos has a harder time doing. So what I'm going to do is I'm going to go to my table, which is above this graph key here. And if you notice when you go to the table, it gives you values of time, and it gives you both the x and the y at each of those times. Now that's convenient, except we need those times every quarter of a second, and the calculator is only giving it to us every second. So what I'm going to do is fix that. So right up here across the top, you see this table set. This is your table setup menu. So I'm going to go second, there. And all this stuff that's here, it's starting at 0, which is fine. That's what we want it to. This delta table, though, that tells you how often it'll change that didn't come out right. That tells you how different the t values are going to be before it evaluates a new one. So we don't want that at 1. We want that at 0.25. So when I go back to my table now, there are all the values. So what I can do now is simply take this thing with a calculator, go back to Desmos, that's what, 11.672, blah, 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 and every place I have a point, I'm going to type in the coordinates of that. So let's see, the first one was 11.672, and then 14.974, They do both need to be in parentheses. And you see what I get is I get a point right there. I would simply repeat that process until I get to the very end. And that's it. Now, you are now ready to build your own Desmos projectile motion simulator.